we have finally talked about enough concepts that we can now discuss the real deal, a circuit, an electrical circuit. What is an electrical circuit? It is a loop. That's really all it is. It is a loop that current flows through. I should say through which current flows, but I just can't bring myself to do it. A loop that current flows through. Okay? It has to be a loop, right? Because current can't just fall out of a circuit and spill on the ground, right? The current has to stay in the circuit. So that's why it fundamentally has to be a loop. And if current is going to flow through it, you probably want to make it out of a conductor, right? Current doesn't flow well in insulators. They have a very large resistance. So let's start by saying the loop is made of a conductor. And you want a good conductor, like a metal, and you want something that's conveniently shaped into different shapes, like a wire. So usually the main thing you're drawing when you're drawing circuits is you're drawing wires. So right now I'm going to draw a circuit made out of wire. It's going to be a loop. And since I'm a big fan of René Descartes, I'm going to draw a square loop like that. Okay, I'm not going to draw a round loop. Okay. Now, so there you go. There's a piece of wire. I didn't even do a good job on it. It's like could have at least. René Descartes would be ashamed if he saw that. There we go. Much better. Okay. There's my loop. It's a pretty boring circuit though, because it's wire, it's full of positive charges that are free to move around, but nothing's making them move. There's not going to be any current in this wire because we don't have a potential difference anywhere. So another thing you need, usually, if you really want to call it a circuit, is a source of potential difference. And that is the battery we keep playing with. Right, just like we drew before, two electrodes, chemical reaction requires them to be at different potentials. So we break our little wire here, we bring in a battery. You'll also see them drawn like this, with a little electrode like that, positive, negative. It's got a voltage V, and you hook one up there, and you hook one up there. And now you might say it's not a loop anymore because you broke the conductor. Well, you can think of the battery as a conductor. So the current can flow, be pushed out of the battery, go back in, and it can go through whatever chemistry is happening here. So it's still a loop. Still, you can think of it as a loop. We know current, let's not do that one yet. And usually, let's say current flows through, made of this, a source potential difference, and usually has a load. And what that means is something resistive in it. If you were to hook this up, it'd be pretty exciting because it would probably catch on fire, right? You would pass, we'll talk later about how current dissipates heat, and you get big current if you just have a wire, and this would burn up. It'd be pretty cool. So let's not do that right now. Let's put in something like a resistor, like the resistors I was drawing before. Here's our resistive load. It's just a cylinder of some material that has some resistance. I'll even write a rho on it so you can remember that's some resistive material, okay? And therefore it has some resistance R. We have a V here, and then what's going to happen is the current is going to go away from the positive and towards the negative. So we have an I. And that same current in a circuit flows everywhere, right? The current will flow out of the battery, around this wire, across the resistor. It'll flow there, it'll flow there. The current can't get bunched up and stop somewhere and flow somewhere else. The current kind of all flows together. So those are the things you need to make a circuit. Fundamentally, it's a loop, but it's good to have a source of potential and a resistive load. And then finally, one more great thing about a circuit is it obeys, a simple circuit like this, Ohm's law, where we have the V that we're applying equals the current that you get times the resistance of the load. So we'll be using that equation quite a bit.